everyone, welcome to the lecture series of compiler design. I am your instructor Kinjal Patel. Topic to be covered in this lecture is basic block and flow graph. So first, what is basic block? A basic block is a sequence of consecutive statements in which flow of control enter at the beginning and leaves at the end without halt or possibility of branching except at the end. Means the continuous execution of a statement is known as a basic block. So in the basic block there can't be a flow of control which can be go toward the other statement. So there should be the continuous execution of a basic block. Hello everyone, welcome to the lecture series of compiler design. I am your instructor Kinjal Patel. Topic to be covered in this lecture is basic block and flow graph. So first, what is basic block? So basic block is a sequence of consecutive statements in which flow of control enters at the beginning and leaves at the end without halt or possibility of branching except at the end. Means the continuous statement execution is known as the basic block. Means there can be the flow of control which can go toward to the other statement. So the following sequence of three address statements form the basic block. T1 equals to A star A, T2 equals to A star B, T3 equals to 2 star T2, T4 equals to T1 plus T3, T5 equals to B star B, T6 equals to T4 plus T5. So this sequence of three address statements forms basic block. Why? Because there is no flow of control, there are no go to statements which are going toward the other three address statement. Now how to partition the three address code into basic blocks? So input is a sequence of three address statement and output, so a list of basic block with each three address statement in exactly one block. Means when we pass the sequence of three address statement, then we want a basic block with each three address statement in exactly one block. So here is the method that first will determine the set of leaders. For that we use the following rules. First rule is the first statement is a leader. Then any statement that is the target of the conditional or unconditional go to is a leader. Then any statement that immediately follows a go to or conditional go to statement is a leader. Means if there is any statement which contains the conditional or unconditional go to which can form a flow of control will become the leader. Now step 2 is that now first we have determined the leader. Now step 2 is that for each leader its basic block consists of the leader and all statements up to but not including next leader or the end of the program. Okay, so for each leader its basic block consists of the leader and all statement up to but not including the next leader or the end of program will become the one basic block. So here is the example that now we'll use that method and we'll partition sequence of statement into basic blocks. So here is the code that begin production equals to 0, I equals to 1, do production equals to production plus A of I star B of I equals to I plus 1 while I less than equals to 20 and end of the program. Okay, so now we want to convert this code into three address code. So first we'll convert this statement into sequence of three address code. Then we'll partition that three address code into basic block. So first line is production equals to 0 which is already in a three address statement rules. So we'll directly write production equals to 0. Then I equals to 1. So here I is also contains only one operator and two operands, so will not change this statement, will directly write I equals to 1. Now the loop is do production equals to production plus A of I star B of I. So this statement contains more than three address code, So now we need to convert this statement into 3 address code using temporary values. So first, production equals to production plus A of I star B of I. So here we want to multiply the A of I by B of I. So first we need to store the A of I in temporary value. Now here, if we consider this I as integer value, then it can occupy the 4 bytes in the memory. So here first we will occupy the 4 byte memory for this I variable. So T1 equals to 4 star I. Now next, B of I, we want to multiply this A of I with B of I. So now again we want to store this I value to A. So here now 4 star I has been stored in T1. So now T2 equals to A of T1, because we have stored this I in T1 temporary value. Now next we want to multiply this A of I with B of I. So again we will store I in another temporary value with 4 byte memory space. So T3 equals to 4 star I. Now T4 equals to B of T3, because I has been stored in T3 temporary value. So now we will add B of T3 to T4 temporary value. So now A of I and B of I has been stored in two different temporary values, which are T2 and T4. So now we want to multiply these two values. So T5 equals to T2 multiply with T4. So now we have multiplied two values and we have stored that value in T5 temporary value. Now next we want to perform addition. So now we want to perform addition of production with A of I star B of I. So A of I star B of I has been stored in T5. So we want to add production with T5. So T6 equals to production plus T5. Now production plus T5 has been stored in T6. Now we want to assign this T6 value to production variable. So now T6 production equals to T6. So now T6 has been stored in production value. Okay, now next is I equals to I plus 1. So I plus 1 will be stored in one temporary value T7, and now we will assign that T7 to I, which is left hand side of I plus 1. So I equals to T7, and the condition is that we will continue this code, we will execute this code while I less than equals to 20. So now here we will perform the flow of control and we will put the condition if I less than equals to 20, then do the following statement, that execute the following statement. So here the loop is starting from the statement 3, that we have assigned T1 equals to 4 star I first. So go to statement 3, that if I less than equals to 20, then we want to execute this loop. So this loop is starting from statement 3. So here go to statement 3. So we have converted this code into sequence of 3 address code, but here this sequence of 3 address code contains the conditional go to loop, that if there is condition I less than equals to 20, then go to 3. So this is not a continuous execution, there is a flow of control which can go toward to the other statement. So we need to partition this 3 address code into basic block. Okay, so now we will apply the rule of partitioning into basic block and we will form these 3 address code into basic block. Okay, so the first rule of partitioning into basic block says that first statement is a leader. Now next it says that the output of conditional or unconditional go to, that statement will become the leader. Means here is the conditional go to loop. If I less than equals to 20, then go to 3. So this output, this statement 3 will become the leader of the 3 address code. So here statement 3 will become the leader. Okay, there are 3 rules for defining or determining the leader, which are: first rule is that our first statement will be leader, then second rule is that the output of conditional or unconditional go to statement will become the leader. So here is the go to 3, that means statement 3 will become the leader. And third rule is that the statement following the conditional or unconditional go to will become the leader. So here there is no statement after statement L, so no need to define any leader. Now step 2. So step 2 says that start from the leader and until next leader comes, that statements will be added in the one basic block. So here first statement is leader and third statement is leader. So until third statement come, the statements which are from 1 to 2 will be in the one basic block. So statement 1 and 2 will form one basic block. So here block B1, we had defined these statements as a B1 block. Now start from leader and form the another block until the next leader comes. So here until step 12 there is no leader in it, so from 3 to 12 it will become the basic block 2. So we will define this block as a B2. So here is the block B2. So we have converted 3 address code into 2 basic block B1 and basic block B2. Now next topic is flow graph. So we can add flow of control information to the set of basic block making up a program by constructing direct graph called a flow graph. Okay, so nodes in the flow graph represent the computations and the edges represent the flow of control. Example of flow of control for the following 3 address codes. So here is the first basic block and here is the second basic block which we have formed. Now we want to form the flow graph. So here we will assign the direction to the one block from the another block. So here from block B1 we need to go toward to the block B2. So here we have defined the flow graph. We have represented this basic block using flow graph by assigning the edges. Okay, so this is the flow graph of the 3 address code. Now next topic is the DAG representation of basic block. So if we want to construct the DAG from basic block, then here is the algorithm that we assume 3 address statement could be of following types. Case 1, x equals to y operator z, where x, y and z are the operands and operator denote the operator. Okay. Case 2, so here x equals to operator y can be also the 3 address statement, and case 3 is x equals to y, there are 2 operands in the single statement. Now with the help of following steps the DAG can be constructed. So step 1, if y is undefined then create node y. Similarly if z is undefined then create node z. Step 2, that case 1 creates node operator whose left child is node y and right child will become the node z. Okay, so left child is y and right child is z of the node operator. And also check for the any common sub expression, that if there is any common sub expression in the 3 address code then we will not form the syntax tree for that DAG. Okay. Case 2, determine whether is a node labeled operator, such a node will have child node y. Means if there is only operator node and there is only one child of that operator node, then that y will become the child of that operator node. Then case 3, so x equals to y, so node n will be node y, means the node which is x will become the node y. Okay, now step 3. So delete x from list of identifiers for node x and append x to the list of attached identifiers for node n found in node 2. Okay, now these are the steps we need to perform to construct the DAG for these 3 cases. So here we have taken the example for which we have constructed the basic block. So here is the basic block 2. Now we want to construct the DAG for this basic block. Okay, so first statement is T1 equals to 4 star I, which is of case 1. So here star will become the parent node and 4 and I will become the child node of star. So here 4 is the left child of star and I is the right child of star, and that star will become the T1. Now next statement is T2 equals to A of T1. Okay, so now the array will become the node and the child of left child of that node will be A and right child of that node will be T1. So here is the T1 node and that array will become the T2. Now again T3 equals to 4 star I. So if there is common sub expression, then we will directly denote that T1 equals to T3. So here T1 comma T3, because we have already defined 4 star I in T1 temporary value. Now next statement is T4 equals to B of T3. So again that B will become the left child of array and the 4 star I will become the right child of array, and that array will be the T4. Now again T5 equals to T2 star T4. So now here is the T2 and here is the T4 left child and right child, and the parent node of T2 and T4 is star node, and that star node will become the T5. Now next statement is T6 equals to production plus T5. So here is the T5 node. We want to add this T5 with production. So production will become the left child of plus and right child of plus is T5. So here right child of plus is T5 and we want to assign this plus as a T6. Now we will assign this T6 to production, that means production equals to T6. So here T6 comma production. Now next is T7 equals to I plus 1. Okay, so here we have already assigned I. So we will directly increment I plus 1 and we will assign that plus node as a T7. Okay, so I is the left child of plus and 1 is the right child of plus. So here plus is stored in T7. Now I equals to T7. So here again this T7 will be equal to I. So T7 comma I. Okay, so here T7 and I are the equal variables. Now step 10 is if I less than equals to 20, then go to statement 1. So now here is the plus node which is I. So now we will perform the condition that I less than equals to 20. There is condition that I less than equals to 20. First I plus 1 has been stored in T7 and now that T7 has become the I. So now our updated I is this plus node. So if I less than equals to 20, then go to statement 1. So here we will define this statement 1. Okay. So this is how we can construct the DAG for the basic block. Applications of DAG. The DAGs are used in following, that first it can be used in determining the common sub expression, that we can determine the common sub expressions in the block and we can delete that common sub expressions, and determining which names are used inside the block and computed outside the block. Then third application is that it is used in determining which statements of the block could have their computed value outside the block. And fourth statement is simplifying the list of quadruples by eliminating the common sub expressions and not performing the assignment of form x equals to y unless and until it is a must. So in this lecture we have learned basic block, flow graph, then DAG construction of basic block and partitioning of basic block. Thank you.